Hey, today we're going to talk about the different types of nuclear reactions and then a little bit about what the function of these radioactive isotopes may be. So we have four major types of nuclear reaction. We have artificial and natural transmutation, which we talked about in 10.1. And then we have nuclear fission and nuclear fusion. So just to refresh, natural transmutation involves the spontaneous decay of an isotope. And how do you figure out if something decays spontaneously is you look in table N. So get out your reference tables and you're going to turn to this page. You're going to look at table N. You're also going to be looking at table O because that talks about the symbols that we use in nuclear chemistry. So if it's on table N, it spontaneously decays. If it gives off any of the particles that are listed in table O, it spontaneously decays. Artificial transmutation. It's when you bombard a non-radioactive substance with one of these nuclear particles. Like, for example, when I take nitrogen and I add an alpha particle to it, I'm going to get it to change. Now, we have two other types of nuclear reactions. We have nuclear fission and we have nuclear fusion. One type is used in nuclear reactors and one type exists on the sun. Nuclear fission occurs in a nuclear reactor. If you don't know what nuclear reactor is, nuclear energy, like on The Simpsons, you know, the big cooling towers look like this. They got smoke coming out the top. But this is where they're cooling down the water that heats up. And nuclear fission involves breaking something. The word fission means to break. So what they're doing is they're taking a larger object, something like uranium, and it's breaking apart into two smaller nuclides. In addition, energy is given off. Now, nuclear fusion happens on the sun, and the only example that they're going to give you is when you add hydrogen together to make helium. And that is the reaction that is occurring on the sun, and it gives off a lot of energy. If we could figure out how to do nuclear fusion, we would have solved all of the energy problems that we have on this planet. However, we have not yet figured it out where it is energy efficient. Now, you're going to go and look in your review book, and they talk about the radioisotopes on page number 84 of this review book. You're going to look at the radioisotopes, and all you really need to know, they're going to ask you about 4, maybe 5 different types of questions. Number 1, carbon-14 is used to date living things. In fact, if I had a woolly mammoth, I'm going to check how much carbon-14 is still available or still present in it that is unchanged, and I can use that amount of carbon-14 still present to determine how long it has been around. Something that is older, like the rocks on the Earth, I'm going to use uranium, and let me just check that number. Uranium-238 is used to date minerals. I don't even have this stuff memorized. You guys, if you want to get 1 point on the regents, 1 point, commit this to memory. Now, I know that radium and cobalt are used to cure cancer. Radium-226, cobalt-60, technetium, or TC99, is used for brain tumors. And finally, iodine-131 treats thyroid disorders. So, there's medical uses for these radioisotopes. If you ask me, I say don't memorize them for the regents, but if you want to get a highest score possible, I would say at least remember carbon-14, remember cobalt, remember uranium. Those are the big 3. Okay?